to mx plus b, right? Or c or whatever, right? What is y-intercept? What was y-intercept? What was y-intercept? What was y-intercept? Come on, I have graduated 20 years ago. I still know that. You guys graduated recently, 2-3 years, right? Just from past from high school. What is y-intercept? Right? Y-intercept is when x value is 0, that is the value of y. So y-intercept means the value straight on the y-axis is called y-intercept. And I'm just explaining because I am not a mathematician. I'm just explaining it in my simple wording. Now, imagine you are going to a Westerner Days, right? You go to Westerner Days. What is Westerner Days? Those who are new here, Westerner Days will be happening here in the summer. What you do? Let's say you go with your parents, and kids will go with their parents over there and enjoy the rides over there and all that. What happens? They pay a price for their entry, right? Any price for the entry to the zoo, or any price to the entry to the excursion, or any circus, or wherever you go, right? What is that price? That is the minimum price that you have to pay, meaning that even if you don't enjoy any rides over there, which is comes for an additional cost, what is the minimum price that you pay? Let's say you pay a price of how much? $20 for sure. That is the minimum price that you are going. That is called y-intercept. Meaning that if you go into a circus or any of these places, what you do? Y is equals to mx plus b. B is what? $20. Definitely, if you are not going to enjoy any further rides there, you are just there and wandering around. At the entry gate, you paid how much? $20. So it means you did not pay for any additional rides, meaning that you did not enjoy any rides. You still going to pay at least what? Y is equals to 20. That is your minimum price, or this is called y intercept. Okay. Now let me tell you that, let's say if you want to enjoy some rides, so on top of $20, what you will do? You will say, I want to enjoy 3 rides, and each ride comes at a different cost. Let's say some is coming at 50 cents, some is coming at $2. So let's say $2. You enjoyed 3 rides for $2 each. What it comes out to be? Total is, so sorry, y is equals to, I'm just too fast. So y is 26. So no matter what you do, you have to pay at least what? $20. And for any additional enjoyment over there, you are paying for 3 rides that you enjoyed, you paid $2 each. So this is what the equation is. I never understand that because it was just dumped on my head. This is y is equals to mx plus b. Y is equal. But think about it now. What is y-intercept? At least whatever that you have to do versus what you have. So this is the, look at this diagram that you're looking at. Simple linear regression. Simple linear regression is, regardless, look at this. This is the production of potatoes in a farm. Y is equals to mx plus b, or y prediction is equals to whatever, however you want to write it. But look at this. b1 x1 is looks like mx plus b, and then b naught is the constant. Y is equals to, so it is the same thing, the constant price. So whether, let's look at this. If you want to grow some potatoes in the farm, what is actually happening? Minimum, if you don't put any fertilizer, you will get 8 tons of output, right? So B naught is equals to how much? 8 tons. You see that 80 in the blue, 8 tons of potatoes, no matter what. If you want to, don't want, and let's say if you put a fertilizer, you will get some additional points. So as you can see, this is the base minimum. You see this? This is y-intercept, 8 tons, 80 is written here. And then if you put some fertilizers, you are seeing some growth in your production of potatoes. So it means, and you see the arrow is going up, meaning that the more fertilizer that you put, the more production that you will get. So this is, for several years, a farmer tried to, when he started in the first year, he got only 8 tons of production without putting any fertilizer. Over the next few years, how many years? 1, 2, 3, 4, 5, 6, 7, 8. Over the next 8 or 9 years, he got different random productions by putting fertilizers. The more fertilizer he put, the more he got. And sometimes he got hit by the storm or he got hit by the hail, then his production was going up, but unfortunately he did not make so much money. As you can see here, it is not so much. We don't know what happened, but we are trying to say that every time he put some fertilizers in there, he got more on the production side. You got it? So this is called simple linear regression. Linear regression means the linear line. When you put, the more juice you put, the more enjoyment you do in the excursion. The more juice you put, the more potatoes you will get. And this is very common in our business scenarios, right? The more we do marketing, the more people we will get attracted. So there are not just examples available in the oil field. There are not examples just available in the farmers world. It happens to us every day, but we just don't notice that what is that y is equals to mx plus b. We now notice that what is y is equals to mx plus b is. We just don't think about it. So somebody has a production. So as you can see, every 1 kilogram of production got increased when he put the nitrogen filter in there. So what is the best line that he can draw? What is the best line that you can draw along these simple linear regression? Would it be, so let's say these are the points, different points. Do you want to make this line? This is the best line. That's what he is trying to mention in here in this slide. If I zoom in a little bit, is this the best line? Is this the best line? What is the best line that is trying to cover as many points in between? What is the best line? This is the best line. The most darkest line is the best line. The one that line above is ignoring all the points that are below. The one that is line at the second most line is not the best line either. The one, what we need to find is that best line. What is that best line is? That is the optimal. So that is where simple linear regression will come into. So I just wanted to give you an introduction to what is mathematical model is and how do you comprehend that into a real world example. So every mathematical model can be represented in a real world, just like an visit to a circus or excursion is there already. Okay, so I'll stop here. All right, so let's get back to it. What we were discussing yesterday about simple linear regression. I showed you this example yesterday about the excursion part. I will share these slides with you shortly as well. But what we discussed about that, we already know y is equals to mx plus b. This is a very similar equation if you look at it. Y cap is equals to b naught plus b1 x1. Don't get confused whether the equation is y is equals to mx plus b or y cap is equals to b naught plus b1 x1. They are different variable names. idea is the same. All right, so idea is the same. If you look at this uh, slide that I'm mentioning, y cap is equals to b naught plus b1 x1. Y cap is equals to dependent variable, y-intercept, b1 is the slope coefficient, and x1 is the independent variable. This is from pure mathematics, which I don't sometimes understand. But here is the real world example. There are so many examples. This can be used in the real life. I actually asked my math teacher when, so I'm going to put that in the chat. In the slide as well. It's worth writing it here because people don't understand the value of it. My math teacher, when he was teaching it a while back, and I didn't realize how present it really it is in our real life. Have you ever been to an amusement park or a theme park? If you have, then you have encountered the slope intercept, and I will explain it to you. You pay a fee to get into the park, and let's say it is $20. On top of this $20, you might have to pay an extra $5 to $10 for riding a certain ride. This is where the slope kicks in. Let's say you go on a ride that is $7 per ride. The equation will be y is equals to mx plus b, would look like something like this. Y is equals to 7 times the number of rides that you take plus 20. The slope of the line would be 7. That is just one of the many examples of the slope intercept being used in the real life. Another scenario include a job where you get paid an hourly rate with the commission selling the X amount of cars of or a computer or whatever you wanted to sell. So let's say if says that, hey, this is you are a salesperson, you will get paid $20 an hour, and if you make additional sales, we will pay you for that additional sales. Remember that excursion park example, $20 an hour, and if let's say you make 3 sales and then multiply by 2 how many sales you made, right? So you made that and you add that, so you will get $26 as an hourly pay. So you can have so many real life examples. So I'm just going to repeat myself. And yesterday we looked at it, the potato example, that on a baseline you will get, no matter what, you will get 8 tons of potatoes no matter what. But the amount of fertilizer that you will use, you will see the productivity increases. We are seeing some of the time, even though we put the fertilizer, we are seeing the less fertility. We are not considering the other factors like hailstorm or other things like that. That's why you are see sporadic points in that chart. But this is what a simple linear regression is, where you are seeing the additional points. So I was showing you yesterday that what would be the best line going through all of the points or covering the maximum number of points. Obviously you will choose one line, and these are the all the possible different lines that you will be thinking upon, but the best possible line is going where? From the center of all the possible dots. That's the maximum best line that you can see. Now if you look at it, the point that I'm going to add today is this, that there is a line that is going here, and if you drop a vertical tangent line from these lines, so please look at this point, this is what is actually that was produced on that year or on that particular time when he planted the potatoes. But what is predicted is, because the best possible line is going through this, what is the best possible line is predicting that the production will be this much potatoes. So what you are trying to see, what you are looking at is to minimize the distance between the actual versus the prediction. The best possible year is what? Is where what your model predicted that these many potatoes will be produced, and the amount of potatoes produced are very close. So what your model predicted, what you ideally want from your forecasting, that's what they keep saying. The forecast price of the house prices will increase by 2023, by 2025. The house that is currently on the market is, let's say, $300,000. By 2025 it will be somewhere around 350. Is your model predicting that, say that if your model predicts 340, is that a good enough? It is good enough. It is really getting close to that. It's only 10 grand away from the predicted price of the houses. But if your house price will be 350, let's say if somebody sells the house in 2025 at 350, and the model predicted that the house value will be 320, then that model is far from the predicted price. So that's what you are looking at, that the model was predicting that the potatoes will be produced like this much, but the prediction is this much, but the production is higher. So actually we did good, better than our model. If you look at this very second point, model predicted that you will have these many potatoes, this many tons of potatoes being produced, but due to some hailstorm or some other unforeseen reason, the production, the actual production, the blue point is lower. Your model actually predicted right, but unfortunately you made less profit. So model prediction versus the model produced. So that's what we want, is that what we want is we are trying to calculate the prediction versus the actual yield. And what our target is the residual is minimum. The residual between the actual minus the predicted should be minimum, and that is what we are going to call the best regression, is the one where the least square is the minimum. So that is where I wanted to say that we are going to use this regression model in the machine learning algorithm, that we are going to predict how many potatoes. So again, there is no one simple examples in the real world. I just mentioned the house price example. There's a potato example that we are looking at it. We also looked at it if somebody went to the amusement park multiple times, and this is how much they spent, right? So you are seeing that from the real life example to whatever real, if you go to Remax or some other real estate, Century 21, they would be asking their data analyst or data scientist that, can you predict me what will be the price of the house in this area, or in Red Deer, in the north side or the south side? We know there's a house prices in the north side are much lower than the south side, but I'm not going into that talk. But they can ask that, hey, can you predict what will be the ballpark figure of the prices of the house that will be sold in 2025 or 2026? So that's what they are expecting you to be predict the market. So when you open up 660 channel news and you look at some of the trends that they talk about, the uh, sometimes they take on some of the experts, subject matter experts from different banking sectors, and they talk on the phone whether interest rates will go up or interest rates will go down. There are always a subject matter experts that they give their opinion. Obviously their opinion may or may not happen, but they are coming based on the mathematical model that somebody has developed for them, and they are giving the answers for that. So that's what I was trying to mention it. So now I'm going to make these slides available to you shortly. open file location. So I'm going to go in the simple linear regression model. Now, my question to you guys will be that when we were studying, we'll come back to the right side of the right side of the screen in a moment. In the last course, at the end of every 15 minutes or 20 minutes when I was dedicating, do you remember that I was importing the libraries, I was importing the data set, I was splitting the data set into training set and test set. I did not did this part. Then I did predicting. I did not did this part, predicting the test set and the test set and the predicting the test set result. No, I did not do that. And visualizing, I did not do that. But do you feel comfortable that I have shown you importing the libraries, importing the data set, splitting the test set into training set and test set, and the rest of the three parts we will learn. So how this is where we will introduce some new concepts to make our model, and then our model will predict something. But some parts we will learn, some parts we already know from it. The last lecture of business analysis and design, or second last, I gave you the PDF file of it, and I also gave you the IPYNB file, which you can upload to the Google Drive or your Google Colab, and you'll be able to run. And I also give you the data.csv file. Remember, I gave you all those three files. If you go back and look at those three files which I gave you, if you have those, please let me know. If you don't have, let me know as well. But I'm not going to go back into those lectures again. But what we did, I imported the libraries, I imported the data set, then I cleaned the data set, I fixed the missing values, I created test set and training set and test set. And my question to you right now is, what was feature scaling? Do you remember feature scaling? What was feature scaling? I did repeat it once at the start of the course of business analysis and design. Then I did towards the end of the course, I explained to you business analysis and design, and I am not going to do it anymore. So you guys already know what I did in that. And it's available as a feature scaling video is available on my YouTube channel as well. But what is feature scaling? You guys have to up the game, up the tempo of your understanding if you are going to excel in your career for this. What do you mean by feature scaling? Please write your answer in the chat box. Anybody else? Thank you, Nandita, but I will explain it again. Thank you, Valerie. Okay, what was scaling? Feature. Good. Thank you, Alexis. Feature scaling is used to normalize the data. What are the two techniques that we learned in the class? I did not explain one. I did explain one. Can you name those two techniques which I mentioned? At least one name. Right? Yeah. Normalization and standardization. Thank you. Thank you. Thank you, Nandita, for the formula. That is the normalization one. So we have learned normalization technique, and I showed it to you in Excel. Those who don't remember, go back to the lecture and understand when I was mentioning the normalization and the standardization. I did it in Excel. Okay, let's scroll down a little bit. This looks a little bit familiar to us. What is the familiarity? Importing the libraries, we already know. Importing the data set, we already know. Splitting the test set into training set and test set, we already know that. Coding part, just copy and paste. So, the scenario that we are going to discuss right now is this one. The scenario is that somebody who has these many years of experience, the salary of that person is falling in that range. So somebody who has 1.1 years of experience, their salary is predicted to be 39,343. Somebody who has 1.3 years of experience, wow, that's a good increment. 1.3 years, expecting it to be 46,205, right? These are the values of it. So if I ask you right now, if you look at it, 3.0 and 3.2, let's say, if I ask you if somebody is falling in the range of 3.1, which is not given here, what will be their expected salary range based on the experience? No, no answer by just looking at the numbers, or no answer by averaging, but I want answers by a linear regression model. So can my model be able to predict that? Yes, it will be able to predict that. What I need to do? I need to train my model based on the linear regression library, which I'm going to do that. But we cannot just simply say, oh, look at these numbers and probably it will fall in this number. No, I want my model to give me an exact number, that what will be the salary of a person who has 3.1 years of experience. And model will answer that. You will not answer that. You will train the model. You will say that, hey model, I'm giving you these sample numbers, sample salaries. Train yourself and give me the predicted salary of somebody who has 3.1 years of experience. We will learn how to do that. But for now, I just wanted to give you a heads up that nothing is lost here. You already know part of it, that how you will import the libraries, how you will import the training set, how you will open the data, bring the data set back into your model, and then what you will do in the training set and test set, and how you will train the model, we will learn it in the next lecture. But I will stop it here.